experiment 2, taking measurements. So this is an experiment to kind of help visualize how to take measurements and further practice the one before this of significant figures and what to report. So here are the materials you need, which is just YouTube links, which are more detailed of when to watch in the experiment. So this goes again in correlation with measuring and what to report and how to be accurate and precise. So we know that in chemistry, we're always trying to be really cautious of what we're using, making sure all of our trials are precise enough to one another and that we're accurate. You are precise when you have your trials are very close with a very small difference between one another, and you're accurate when your average of all of your trials is close to the true value. Again, this is review, so I'm going a little bit fast. Now, you're not always trying to just be accurate or just precise. Your goal is always to be both, because you want to have all of your trials very close, because that means you're very reproducible. And obviously you want to get to your end goal. When you're measuring length, all measurements are estimated values. They're obtained by using a measuring device that is marked with a calibrated scale. The scale contains marks and printed numeric values at regular intervals. So there's a degree of uncertainty, just like what we've done in the past, of where you have to guesstimate that last little digit. Here's a little diagram where you have two different rulers. One where you just have ones. You have no other indication of where you can guess. So here, you know you were between 12 and 13, but you don't know exactly how much, so you're just going to say 12.5. In the other ruler, you have a lot more smaller markings where you can actually make a little bit better of a guess, and notice that it's between 0.5 and 0.6, where it's 12.55. Volume, also very, very similar, depending on the device that you're using. When you're measuring volume, you take the volume of the liquid that's curved, where the meniscus is. Wherever you see that the meniscus drops down, you record that volume. You always want to drop to eye level so you can visualize exactly where the meniscus is. And again, find your certain digits and you record all certain and the one uncertain. So that's length and that's volume. If we wanted to know density, we have to measure volume and length. Density is the amount of mass of a substance over the amount of volume. We do not have a way to measure density directly, but we do have ways to measure volume and to measure length. So we can determine the amount of mass, the amount of volume, to then determine the amount of density experimentally. And then you can evaluate the precision and accuracy of your results through something called percent range and percent error. Percent range helps you understand how precise you were by taking the highest experimental value that you had minus the lowest. So from your trials, right, the highest number and the lowest divided by your average times 100. That tells you how precise you were. What was your range? Did you have a large gap between your numbers? Did you have a smaller gap between your numbers? Percent error then tells you exactly how close you were to the true value. Now, you can look at your numbers and say your true value is 10.5 and your average is 9.9. Oh, I'm probably so close. But a percentage will tell you more. You're 2%, you're 7%, etc. Usually in chemistry, we want a percent error of 2% or less to be really confident that we're accurate. So your procedure for this lab is to watch the YouTube videos and fill out the data sheets with the calculations and answer the questions, submit to Canvas. Again, you must write in blue or black ink. You must show all of your work and have your name on it as well. So I will walk us through the steps a little bit here. So you watch the YouTube video demonstration and it's going to go through all these steps here. It'd be a good idea for you to read this before you actually watch the video. So what you would do is you determine and record the mass of an empty graduated cylinder. The goal of part A is to determine the density of a known liquid. Well, How do you get the mass of a liquid? You can't pour the liquid on a scale, so you have to use a secondary device. What we're going to use is a graduated cylinder. So first, you have to actually take the mass of the empty graduated cylinder. Again, recording your significant figures properly, all of these certain digits and one uncertain. Then, after you take the mass of the empty beaker, you're going to fill 25 milliliters of a known liquid into the cylinder. Before you move on, I would record. Now, even though you want 25, that doesn't mean you're going to get exactly 25. You might have 25.5, 25.10, etc. Depending on how many digits you want, record your volume. Now that you have it inside the graduated cylinder, you replace it on the scale and you record the mass. So then you have the mass of the cylinder and you have the mass of the cylinder and liquid. So how can you find the mass of the liquid? You would subtract, right, to get rid of the secondary substance. So you subtract the two to get just the mass of the liquid. You already recorded the volume, or if you didn't, you can do it then because you didn't lose any volume. And then you would find your density. That's one trial. Now again, we don't just base off our results of one trial. So you would redo this experiment. Super important is to redo everything. A lot of the time students say, okay, well, I'm using the same graduated cylinder. I don't have to weigh it again empty. That's wrong. You always want to repeat all of your steps using the exact same graduated cylinder, the exact same scale, exact same any other devices that you used for your first trial. So you take your graduated cylinder, you empty it out, and you completely dry it. Then you repeat the steps from above. You do this so that you have 3 trials total. Each time, though, you are changing the volume. In the second time, you add 35 milliliters instead of 25. And in the third time, you add 50 instead of 25 or 35. You then finish by doing any of the calculations, where subtracting to find the mass and finding the density. Now, since you're not physically doing this experiment, you're going to use the following data written here in step 11 and writing that in your data table and doing the appropriate calculations. Watch the video to really see how the numbers are recorded and how the experiment is performed. So that's the density of a known liquid. The density of a regular solid. So a YouTube video demonstration for how to do this physically in lab. You would be given some kind of a sample and you'd identify what the sample is. Now this is a solid, so how can you take the mass of a solid? You can place the solid on your scale and record the mass. Again, all certain digits and the last uncertain digits as well. Now, when it's a solid that's regular, there's usually some way to calculate volume. Volume is the amount of space occupied by a substance. When it's a rectangle, we have length times width times height. If it's a cylinder, we have the volume of a cylinder. If it's a sphere, we have the volume of a sphere, etc. So you'd have to take a few length measurements. So you measure the height of your sample using your metric ruler and again reporting the correct number of significant figures. Let's say you have a cylinder, so then you also want to measure the diameter, which again, a cylinder looks like this. You have the height, which you would measure with a ruler, and then the diameter, which you would measure with a ruler, reporting the correct number of significant figures. Using the formula, volume is equal to pi 3.14 r, which is the radius, and radius is equal to 1/2 times the diameter times your height. All of that together will give you your volume. Now, really important, if you have your radius and it's some number in centimeters and you square that, you get centimeters squared. And then you multiply that by your height, which is also centimeters, you get centimeters cubed. Now remember, we want density, which is grams per milliliter or grams per centimeter cubed. 1 milliliter is equal to 1 centimeter cubed. Making sure you're in the right units. So if you did everything in millimeters, you want to make sure that you convert to centimeters. So you can then convert to volume, a more liquid volume unit. You perform any additional calculations, making sure you follow the order of operations and completing the correct number of significant figures. You would then repeat for a different solid. Let's say a rectangle, where you would then do length times width times height. Now, what I want you to notice is the difference, right? So here, taking the volume was a little bit different because we can't just read it from a graduated cylinder. We had to do it metrically with a ruler. But the mass was just placing it on a scale. In part A, taking the liquid volume measurement was easy because we'd read from a graduated cylinder, but mass was different. We had to use a secondary container to calculate the mass of a liquid. Take the container empty, pour the liquid in, then take the mass with the liquid and subtract. Here's the sample data that you will use to fill out and answer the following questions in your data sheet. So then part C is taking the density of an irregular solid. Now this means the solid is not, you can't really measure anything metrically and find the volume. It's not a regular shape. Here are the YouTube video link to watch. And what you do is a method called water displacement. So you add around 25 milliliters of water to a 50 milliliter graduated cylinder. You read and record again the volume to the correct number of significant figures. You weigh the graduated cylinder containing the water in it and record its mass. Then what you do is you carefully add the irregular sample into the graduated cylinder. What's going to happen to the volume? It will rise. Before you record the volume, you're going to weigh the graduated cylinder that contains the water and sample and record its mass to the correct number of significant figures. You read and record the new volume, also reporting the correct number of significant figures, and then the difference between the new volume and the original 25 milliliters, again writing the exact 25 that you get, is the volume of the irregular solid. You repeat the entire procedure using a different sample and perform any additional calculations. You can find the mass by taking also the difference of the sample where you weighed the graduated cylinder with the water and taking the difference of the mass of the graduated cylinder with the water in the sample, taking just the mass of the sample. This is the data that you'll use for this trial. So different ways of calculating density depending on what you have, a liquid, a solid, or an irregular solid. So then here, this is the sheet that you have to turn in. Make sure that you write your section, and this is Chem 31, whoopsies. And your name. So, density of the known liquid. Anything that has an asterisk is where you'll be showing your calculations, correct number of significant figures. Fill in all of your numbers given to you from the procedure, making sure you can show all of your work here on the side, and that you have the correct number of sig figs.